You finish the last bite. Something sweet, a pastry, a soda, a handful of candy from the jar on someone's desk. For a few minutes, you feel good, maybe even sharper than before. Then, somewhere around 3/4 of an hour later, it arrives. Not hunger, exactly. Something heavier. Your focus thins out. A low irritability creeps in from nowhere. Your hands might feel slightly unsteady. All you want, suddenly and specifically, is more sugar. Right now, not later. Most people call this a sugar crash and leave it there, as if the story ends with the word crash. It doesn't. There's a very specific alarm system inside you that just went off, and it's not measuring what you probably think it's measuring. Here's the strange part we're going to get to. This system was never designed to detect low sugar the way you'd assume. It's watching something else entirely, a variable most people have never even heard described. And once you understand what it's actually tracking, the whole crash stops feeling like a mystery and starts feeling like a very literal alarm bell doing exactly its job. But to get there, we need to follow the sugar itself, starting from the moment it hits your bloodstream. The moment sugar is absorbed from your gut, it enters your blood as glucose, and your blood glucose level begins to climb. How fast and how high depends heavily on what you ate. A food that breaks down quickly, like refined sugar or a sugary drink, sends glucose into your bloodstream in a sharp, steep spike. A food with more fiber, fat, or protein alongside it releases that same sugar far more slowly. Piece 1. The steeper the spike, the more dramatic everything that follows is going to be. This is where the story really starts. Your body does not like a sharp spike in blood glucose. Too much circulating glucose, sustained for too long, causes real damage throughout the body. So there's a fast, powerful response built to bring it back down. That response comes from your pancreas, in the form of a hormone called insulin. Insulin acts like a signal broadcast to cells throughout your body, telling them to pull glucose out of the blood and either use it or store it. The sharper the spike, the more insulin your pancreas releases to match it. And matching a very steep, very fast spike is a difficult, imprecise job. Piece 2. Sometimes, in the effort to bring a steep spike back down quickly, the pancreas releases more insulin than the situation strictly needs. Glucose doesn't just return to its normal baseline, it can overshoot, dropping below where it started. This is the part most people have actually felt without ever having a name for it. Not simply sugar running out, an active overcorrection, swinging past the target in the other direction. And this is where the story gets more interesting than low blood sugar. Because your body doesn't just quietly notice a low number and move on. It has a dedicated detection system for exactly this moment. One built into a small cluster of neurons in the hypothalamus, backed up by sensors along the vagus nerve running from your gut to your brainstem. These sensors are part of what's known as the glucose counter-regulatory system. And here is the detail almost nobody talks about. Piece 3, and the actual reveal of this whole story, that system isn't only watching the absolute number. Research on glucose regulation shows it's highly sensitive to the rate at which glucose is falling, not just how low it eventually gets. A blood sugar level that would feel completely unremarkable if it dropped slowly over several hours can trigger a full alarm response if it drops the same amount quickly. In other words, the crash you feel isn't necessarily your body running out of fuel. It's frequently your body reacting to speed, to how fast the number is moving, not simply where it lands. Once that system decides the drop is happening too fast, it doesn't respond quietly. It calls in backup, a small cascade of hormones whose entire job is to push glucose back up as fast as possible. Glucagon, adrenaline, cortisol. Adrenaline in particular is why a sugar crash doesn't just feel like tiredness. Adrenaline is the same hormone involved in a fight or flight response, which is why a sugar crash can come with a faster heartbeat, a jittery feeling, even a flash of something close to anxiety, despite nothing threatening actually being present. Piece 4. Your brain, specifically, is unusually intolerant of any of this. Unlike most tissues in your body, which can run on multiple fuel sources, your brain, under normal conditions, depends heavily on a steady glucose supply. It has no meaningful reserve of its own, so even a temporary, rapid dip registers to your brain as something closer to an emergency than a minor dip would to, say, a muscle. That's why the crash doesn't feel like general fatigue. It feels specifically cognitive. Foggy, irritable, short-tempered, harder to concentrate, because the organ most affected by the dip is the one running the rest of the show. So, 4 pieces. A steep glucose spike, sized to whatever you ate. An insulin response strong enough to overcorrect it. A detection system tuned to the speed of the fall, not just the depth of it. And a brain with almost no patience for the interruption. Put together, they explain something that used to feel like a mystery. Not why you feel bad after sugar, but specifically why it takes about that long, and why it hits the way it does. Which brings us to a question we haven't answered yet. Why does the body seem so quick to overcorrect in the first place? Why does a system meant to protect you from a drop in glucose so often swing past the mark? One possibility researchers have pointed to involves timescale mismatch. Human insulin regulation evolved across a very long stretch of time in which concentrated sources of fast sugar, the kind delivered instantly by a soda or a candy bar, were vanishingly rare. Most sugar available to earlier humans came bundled with fiber, inside whole fruit, released slowly. A regulatory system calibrated for a slow trickle of glucose, suddenly facing a sharp, concentrated flood of it, is working with a mismatch it was never tuned for. Scientists don't claim this fully explains every case. Individual insulin sensitivity varies widely, and some overcorrection is normal and harmless in itself. But it's a serious, evidence-consistent explanation for why a system built to protect you can, under modern conditions, occasionally overshoot the very thing it's trying to prevent. Now here's where the loop most people get stuck in actually starts, and it explains something almost everyone has experienced without connecting the dots. Somewhere in that jittery, foggy, irritable window, the single most available fix always seems to be more sugar. And it works. Almost instantly. Your blood glucose rises, the counter-regulatory alarm quiets down, and you feel better within minutes. But that relief is, in effect, restarting the exact sequence from piece 1. A new spike, a new insulin response sized to match it, a new overcorrection somewhere behind it, waiting on the same roughly 45-minute to an hour delay. This is why a sugar crash so often doesn't resolve after one snack. It can turn into a slow rolling sequence across an afternoon, each fix only pushing the same alarm further down the timeline, instead of turning it off. None of this means your body is broken, or that this happens with equal severity to everyone, or that a piece of cake is a biological emergency. Individual responses vary enormously depending on what else is eaten alongside the sugar, overall metabolic health, sleep, stress, and simple genetic variation in insulin sensitivity. For most people, an occasional post-sugar dip is an uncomfortable but ordinary swing of a system working as designed, not a sign of a serious problem. Persistent or severe symptoms are a different matter and worth discussing with someone qualified to look at your specific situation rather than diagnosing from a video. What's genuinely new here, for most people watching, isn't that sugar can make you feel bad afterward. Most people already suspected that. It's the specific mechanism underneath it, an alarm system tuned to the rate of a fall rather than the number itself, borrowed from a regulatory system that evolved for a world without concentrated, fast sugar at all. The crash isn't your body failing. It's a fast response protection system doing exactly what it was built to do, reacting to a kind of glucose spike it never had much practice handling. Somewhere, right now, someone is finishing a sweet snack, feeling briefly better, without any idea that a cascade is already quietly beginning. A spike, an overcorrection, an alarm tuned not to how low their blood sugar will go, but to how fast it's about to get there. In about 45 minutes, they'll reach for something sweet again and call it a lack of willpower. It never was.